So today we're going to talk about correlation, and in order to do this properly, we're going to be actually exploring it in the Texas Instrument, the TI-84, or you will be doing it in the Statlet that we use. Both of those are linked in the folder above. If you do not have a TI-84 physically, then you can go up and download the version that is used on your Chromebooks. So again, that's linked. We will be using those tools, so I wanted to prepare you for that first. Now, in number 6, you'll notice that all they're asking you there is to estimate what the correlation will be like. So I have my answers here, but let me talk through it a little bit. In A, it definitely has a strong positive linear association. I would predict that to be about 0.9. That's a positive value, so 0.9. This one right here in B actually has like 0 association. I can't tell if it's positive or negative. It really has 0 linear association. So my R would be 0 for that one. In this one, it's very weak in C. It's very weak association. 0.7 would be too high for that one. So that's a pretty weak association, but it is still positive trending. So I'm going to say that that has an R value of about 0.3. In D, it's kind of the opposite. I kind of see this negative decline trend right here, but it's very weak. I would call that an R of negative 0.3. And my last one in E, this is definitely a strong negative association. So I would place that at a negative 0.9 as my R value. Okay, moving on to 7. Number 7 asks about a couple blunders that are happening within these different scenarios that they're going to give you. So in A, it says there's a high correlation between the gender of American workers and their income. The problem is you can't calculate an R value or a correlation when you have categorical data. They're saying between gender and income. Income is fine, but gender is definitely not a categorical measure. I'm sorry, is not a quantitative measure. It's a categorical measure, and we can't do that with a linear regression line. For B, it says we found a height correlation, R equals 1.09. I'm going to stop there. I don't have to read any further. R values can never be over 1. 1 is a perfectly linear relationship. An R value of 1.09 is not possible. In C, it says the correlation between planting rate and yield of corn was found to be R equals 0.23. I have no issue with that until it says bushels. R has no units of measure. It's not like R equals 0.3 inches, or in this case, bushels. That's not a thing. R is an association in how strong something is, but it has no unit of measurement. In number 8, you'll notice that I actually did a scatter plot by hand, but I'm going to take you over right now to look at how to do this in our Statlet, which I think is more useful and something that you can use moving forward. So what I would do for this one, and I'll actually leave this up so you can compare them, I would probably put that my explanatory variable is women's heights, and then the response is men's. Now, this one, I actually would take either direction here, but in the problem, in the context of the problem, she's using her roommates' heights to predict, or to see if there's an association with them dating taller men. So that's what we're kind of looking at here in this scenario. So my explanatory, I'm going to take women's height and then look at the men's height from there. So in this data, I need to go back to it really quick. I have right here 66, 64, 66. I should actually grab that out. 66, 64, 66. And then I have 65, 70, 65. So going back, I'm going to move them close to each other. 65, and I can't remember the other one really quick, 70 and 65. Those are in inches. And now we have the corresponding, you have to line them up, the corresponding heights for males. So 72, 68, 70, 72, 68, and 70. And then we have the last 3, 68, 71, 65, 68, 71, and 75. Let me make sure I have that. Oops, and 65. I'm glad I checked. Okay, so now that I have the values put in, I'm going to hit begin analysis. And there is my scatter plot. You'll see it looks like that one. Okay, so there is my scatter plot. It asks on there a couple questions after that. It says, describe the association. I definitely see this positive trend like in here somewhere where I think it's like a moderate. I don't know that I would say that it's super strong because there's definitely some variation, but I'd say like a moderate positive linear association. And I kind of look at this and I go, well, if I had to guess an R value, it might be like 0.6 or so, like maybe 0.6. Well, if you look here, you actually have the ability to look. It says calculate correlation, and our correlation is right there. It's 0.565. Okay, we're going to get into tomorrow. You can actually even calculate the least squares regression line here, which I will definitely talk more about that later. But that shows you that you can actually see the correlation here. Super, super useful. Okay, I'm going to show you the next one in the TI. So I'm going to skip that for now, but I'm going to go back to what we were working on. And we're going to go down to number 9. So in number 9, it says, now use this data that you just had, women's and men's height. If we changed all men's heights by 6 inches, okay, I subtracted 6 inches from every single one, what would happen with the R? Okay, well, the R value would actually stay the same. Okay, so how would R change if all the men were 6 inches shorter than the heights given in the table? Does the correlation tell us if women tend to date men taller than themselves? So no, it would actually, they would all stay the same. All it's showing is an association between these two variables. So that right there would not, if I switched every single one, it still would show the same exact strength. Just by changing, as long as you're changing all the values, whether you're multiplying, adding, or doing anything, then your R will actually stay the same because all it's measuring is the strength. It's only measuring the strength. I will tell you, on the flip side of this, if I just were to change one value, like I made this value instead, like I pulled it down here, that will have an effect on your R value. But if you change all of them, it's actually going to have no effect. In B, it says if heights were measured in centimeters rather than inches, how would the correlation change? The answer to that is it would not change. If all the values are going from inches now to centimeters, there's still that same exact relationship. In number 10, the last one for today, it says in the figure below, you have the child's IQ test and then their reading test scores. It says, what effect does this low outlier, so I'm guessing that one right there, what does that have an effect on the correlation? I can tell you if I were to get rid of it, so I'm covering it up right now, I would have a pretty moderately strong association like this, but by putting this one in, we're going to kind of talk later about my my slope. My slope is actually going to be, whoops, and it should not be D, actually. I'm actually finding this right now. It actually would make the correlation close or equal to 0. I meant to put C. Sorry about that, guys. The slope would be negative, but R would be close to 0. Your R would be close to 0. Okay, there'd almost be no association. Now, if I took that point out, so I'm going to cover it up again. So if I cover this up right here, then you can kind of see a positive trend, but when I have this one in there, there's really not any kind of positive trend.